For any positive integral index, x plus a whole power n is equal to nc0 x power n plus nc1 x power n minus 1 a power 1 plus nc2 x power n minus 2 a power 2 plus so on ncn y a power n. So for any positive integral index, that means for this index should be a positive and an integer, positive number or integer number. So it should be a positive integer number, it cannot be a fraction. So for a binomial theorem to apply, we need the index as positive integer. So here if we see nc0, nc1, nc2, nc3, so on ncn, these are called as binomial coefficients. So we know that some nc0 value is 1, nc1 value is n, nc2 value is n of n minus 1 by 2. So how did we get here n of n minus 1 by 2? We know a formula, ncr is equal to n factorial by n minus r factorial r factorial. So by using this formula we got this. So how we got this? nc2 n factorial by n minus 2 factorial into 2 factorial. So this can also be written as n into n minus 1 into n minus 2 factorial. Okay, next n minus 2 factorial into 2 factorial, 2 into 1. So n minus 2 factorial, n minus 2 factorial gets cancelled and we get n of n minus 1 by 2. So this is the way we are going to get the coefficients values. Now coming to the special cases, a minus b whole power n. So till now we have seen a plus b whole power n, x plus a whole power n cases, but now here it is given a minus b whole power n. So it can also be written as a plus of minus b whole power n. So applying the binomial expansion here, nc0 a power n minus 0 is a power n, minus b whole power 0 is 1, so leave it as it is. Next nc1 a power n minus 1 minus b whole power 1 plus nc2 a power n minus 2 minus b whole power 2 plus nc3 a power n minus 3 minus b whole power 3 plus so on ncn a power n minus n is a power 0, nothing but 1, so leave it. Next minus b whole power n. So now if you observe here, it is nc0 a power n and here it is minus b whole power n, minus b whole power 2, minus b whole power 3. We know that any negative integer which is having the power as odd, it becomes the negative number. So here it is odd, here 3 is odd, and next 5 is odd, 7 is odd. So such type of negative numbers having the power as odd, it will becomes the negative term. So nc0 a power n, so when as it is odd, the minus comes outside, minus nc1 a power n minus 1 into b plus minus b whole square. As it is even, it becomes minus into minus plus, so nc2 a power n minus 2 minus b square. Next, as it is odd, minus b whole power 3, minus into minus, we get minus, so put it as n, instead of plus you put it as minus nc3 a power n minus 3 b cube plus so on ncn minus b whole power n. We cannot decide whether it is plus or minus because we don't know the power whether it is even or odd. So coming to next expansion, 1 plus x power n is equal to NC0 1 plus NC1 x power 1 NC2 x square plus NC3 x cube plus so on NCn x power n. So if you observe here, there is no other variable except x. Why? Because every time any power of 1 is 1, so it is left out. Next, 1 minus x whole power n. If we consider here the same thing, if we compare this a minus b whole power n with the 1 minus x whole power n, we get the same manner of result here. NC0 plus minus NC1 x plus NC2 x square minus NC3 x cube plus so on NCn minus x whole power n. So here if you observe here, minus plus minus, alternative minus plus negative terms are here coming. So if you observe here also the same way, minus plus minus. So whenever we get this type of expansions, 1 minus x whole power n, a minus b whole power n, we get the alternative symbols of addition and subtraction, minus or plus. Now coming to general term, a plus b whole power n. We know that a plus b whole power n expansion is NC0 a power n plus NC1 a power n minus 1 b power 1 plus NC2 a power n minus 2 b power 2 plus NC3 a power n minus 3 and b power 3, so on NCn into b power n. So we have the general term formula as NCr x power n minus r b power r. So this is the most important formula of the binomial theorem. So in this formula, if you observe, whatever the term which is in the r place will be the power of b, and power of b will be 1 less than this r plus 1 term. So now for example, find the coefficient of x power 5 in the expansion of x plus 5 whole power 9. Now if you see here, we take the general term as it is 9cr x power 9 minus r, so b is 5 power r. So in order to find out the coefficient of x power 5, we have to equate the powers of x to 5. So 9 minus r is equal to 5, r is equal to 4. So after getting the r value, if we look here, if we substitute in place of r 4, we get t 4 plus 1 is equal to 9c4 x power 5 and 5 power 4. So this is the value we get. So here the coefficient of x power 5 is 9c4 into 5 power 4. So here the power of b, which is nothing but 5, is 4. The same term in the r place is 4. Similarly, the power of 5 is 1 less than the in place of r plus 1 term. So here it is 5 and here 1 less than 5. Now the middle terms of the binomial expansion. So whenever we find the middle terms of the binomial expansion, there arises two cases. The first case is when n is odd, and second case is when n is even. So n is nothing but index. So whenever the index is odd number, the total number of terms will be n plus 1, which is even. So here whenever the index is odd, we get the total number of terms as even. For example, let us say we got 10 terms in the expansion. So the 10 number is an even number, so middle terms will be the 5 and 6. So middle terms are 5 and 6. So then the middle terms will be two numbers. So what are the middle two numbers? N plus 1 by 2 term and n plus 1 by 2 plus 1 terms are the middle two terms. So for example, when n is 7, we get total number of terms as 8. So if the total number of terms are 8, the middle terms are 4th and 5th terms. So T4 is equal to T3 plus 1 is equal to NC3 a power n minus 3 b power 3. Similarly, T5th term is equal to T4 plus 1 is equal to NC4 a power n minus 4 b power 4. So these are the two middle terms. So we get two middle terms when the index of the given binomial expansion is odd. So coming to the second case, if you see here, when n is even, total number of terms will be n plus 1, nothing but they will be odd. So whenever we get the total number of terms as odd, there will be only single middle term. So n plus 1 by 2, nothing but n plus 2 by 2. So n by 2 plus 1 term. So n by 2 plus 1th term will be the middle term of the expansion whenever the index is even number. For example, when n is 10, then total terms will be 11 terms. So what is the middle term when the total terms are 11? 6. So 6th term will be the middle term. So T6 is equal to T5 plus 1 is equal to NC5 a power n minus 5 b power 5. So this is the way we get two cases in a binomial expansion while finding the middle terms. So when n is odd, we get two middle terms. So when the index n is even, we get single middle term in the binomial expansion.